S. Gopakumar, who was the director of Cape Electric. He's an engineer, electrical engineer, also one of the member in the working groups of Indian and International Electrical Commission, that is IEC, and the technical coordinator of Lighting Awareness and Research Center LARC Trivandrum. Having more than 27 years of experience in electrical safety, lighting protection, and EMI and EMC of electrical installation. He has conducted more than 1,000 site studies, hundreds of site studies on failure in electronic equipment and presented more than 1,000 seminars and training programs. He has also published articles about safety in various magazines and published his own book, The Missing Link, in the subject of electrical safety. Ladies and gentlemen, we are very fortunate to attend this wonderful session on electrical safety. And I now welcome.
Thank you very much, Mr. Dominic. Thank you very much, Sharma ji. So it is my turn to start the presentation now. So thank you very much, Sharma ji, for the nice introduction, and thank you very much, Mr. Dominic. So this is the second part of our program on fire due to short circuit. As Sharma ji told, always, every time the results say that electricity created fire and a lot of people are dying. And we always have an interesting discussion about the standards and code of practices. So my experiences, I am a member in the National Building Code in the Electrical Committee. I am in the National Electrical Code of India. A new NEC is upcoming. Probably in next 2-3 months, the new NEC will be out, which will have a lot of new improved safety measures. I am also a member in the TC64 of IEC, International Electrotechnical Commission, in some of the working groups related to safety in the low voltage electrical installation. Also, I am in the TC81 lightning protection group in the IEC and the SC37A, which is the surge protective device. So basically, my nowadays last 3-4 years, I'm spending more time in the standardization work rather than my business. Now, if we look at how deep these standards are, to explain you very simple, IEC had standards even for insect repeller. Even to that small, you must have seen insect repellers outside the hotels and small restaurants. There is an IEC standard even available for such kind of a very small product. That is the depth the standards are made. But are we following these standards is the biggest question. When it comes to electrical safety or electricity, I have a feeling that people try to read or people try to understand the standard, not to follow it, but to find out how to violate. So rather than following, the deeply the lines are understood to violate it. As a result, more than understanding, we have more misinterpretation of the standard. As a result, what happens is we don't follow or we don't really take up the subject seriously and do it. Now, coming to my presentation, first I will make a small introduction about my company, Cape Electric. We are, most of you are aware, we are into electrical safety testing and training. We are into earthing system, different kind of earthing system in the sense nowadays, functional or foundation earthing. That means make use of the structural steel in the building. And you don't need any extra earth electrodes in your building. That is the new concept, including extra high voltage installation. You can do this installation. We are already executing hundreds of projects across India. We are also into the business of double insulated electrical enclosures, IP65 enclosures, industrial plugs and sockets and so on, basically electrical installation material. And we are also into EMI-EMC. Or electromagnetic pulse. We are designing a lot of installations where EMP protections are made. This is about the short introduction of the company. And what business we are doing is, about the company. We are a 25 years old company. We have completed, we are going to complete 25 years in next month, February 15th approximately. We are established in 1995. At the moment, we are over 200 employees in 2 manufacturing locations, operating all over India, doing hundreds of projects in India with respect to safety, especially the new and the upcoming buildings. We are actively into training and design. I'm sure you are aware what kind of trainings we are making. So the company started as a Cape Electric Corporation as a proprietorship firm, but then we converted to Cape Electric Private Limited, and now the company is Cape Electric Private Limited. As all of you are aware, fire is a big threat to our country, especially fire due to short circuit. And the claims, very well, some states say 60% fire are due to electricity, some states say 80% are due to electricity. And if you ask me whether I believe it, honestly speaking, I believe this, because I am doing several inspections or, the site studies and so on. Most of the time, electricity is the reason for igniting the fire. Probably something else burns too much and becomes a major fire, but the ignition starts from the electricity. As Sharmaji told about the incident in the Gujarat hospital, I'm just showing you the video. Probably people, those who have attended the previous programs, they know the video very well. This video is from the Times of India. What you should understand is the nurses or the staff, they started running and they have identified something. They are trying to remove the patient from the ventilator, but within few seconds, exactly speaking, on the 17th second, small spark happens. 27th second, one more spark, and at 40th second, a major blast happens. And within 1.5 minutes, this particular room was full of smoke. So this whole thing happened within 1 or 2 minutes. Technically speaking, the electrical standards are written and followed in such a way that such electrical accidents are not supposed to happen. Number one, in this particular case, the fire started from an electrical apparatus, let us say a ventilator. Probably an air conditioner, this can start, maybe a refrigerator it can start, maybe a heater it can start, any kind of electrical apparatus fire can start. But those product standards are made in such a way that these equipment are not supposed to produce heat. It is not supposed to ignite a fire accident. The safety measures are made internally. In other way, if I say, electrical equipments designed and tested as per the IS standards are supposed not to create fire from electricity, or the chances are absolutely very, very small. But once when you connect this electrical apparatus into your power supply, not only the apparatus has got certain limitations. For example, line to neutral overcurrent, the device, overcurrent and short circuit, the device is able to withstand by its own because it has got an internal protective device and it will disconnect. Whereas in case of an earth fault, how you are connecting the earth outside is the important subject. Whether this protective device which is put inside the equipment is able to protect from an earth fault. So there, the system earthing comes into picture, and system earthing is decided majorly by the power supply company, and the power supply company are supposed to follow the Central Electricity Authority regulations. This part I covered in my first part last week, 2 weeks back, but still I show you just for people, those who are new in this program. We are supposed to get for low voltage supply, we are supposed to get a TNS or a TNCS supply from the electricity supply company. Regulation 14, 15, 16 of the Central Electricity Authority safety regulation says the power supply company is supposed to give an earthed conductor, means a TNS system, or an earthed neutral conductor to the consumer. Then they say this particular conductor, earthed neutral or earthed conductor, shall have a indication of permanent nature, and no cutout or link shall be inserted in this particular line. And then here, where I'm moving the cursor, the electricity supply company is supposed to give an earthed terminal to the consumer, means this earthed terminal is connected to the neutral of the power supply company through a metallic conductor. So that metallic conductor fault return path is very, very absolutely important, because in India, the power supply is the electricity distribution company is giving you a cutout fuse, a porcelain fuse, and this porcelain fuse is supposed to protect our installation in case of a fault. And for this porcelain fuse, it requires a lot of energy to blow or to break, and that energy requires a lot of current, or enough fault current should flow to disconnect the supply. So these are very well documented in the regulations. Also, how to make the meter board is documented in several places, especially the REC documents, Rural Electrification Corporation documents. Since 1970s, these documents are in practice. But unfortunately, what happens is, one moment, let me hide this. Yeah. Unfortunately, what happens is we are supposed to get the TNS supply, but our electricity supply company generally don't provide this fifth conductor. So they don't provide the link between the earth and the earthed neutral conductor. As a result, the network is actually violating the regulations 14, 15, and 16, and the network becomes TT instead of a TNS system. Say, for example, in the hospitals, there are hospitals, those who have got multiple low voltage supply. I have seen a hospital a year back. They have got 4 connections, 4 LT connections, and there are a few operation theaters as well in the hospital. So what happens, if because of the violation from the electricity supply company, due to earth fault, let us say, for example, on the video which we have seen, the ventilator started the fire. Your protective device will not trip. You need to have specific protective devices, additional safety measures for such, disconnection. So basically, if we look at the fire accidents in the shops and smaller units and LT supply, most of the time the accidents are due to the violation of the regulation, especially by the electricity supply company. So ideally, these violations shall be treated as a criminal offense. I repeat it always, and in several cases there are the authorities are also taking some measures. Now, case 2, Regulation 33. Regulation 33 of the Central Electricity Authority Safety Regulation says. You can read the underlined part. Installation and equipment of voltage not exceeding 650 volt shall be at least 1 mega ohm. What it is? This is the minimum insulation resistance required for in an electrical installation. 1 mega ohm between phase conductors to earth, between neutral conductor to earth. You have to disconnect the neutral and earth link, and you are supposed to measure the insulation resistance, and within your installation 1 mega ohm is the minimum insulation resistance required. I am explaining this because at the last part of the presentation I will show you a product which is sold in the market which actually violates this requirement. Also, Regulation 30 says every 5 years we are supposed to, the power supply company is supposed to do this particular testing and ensure that the insulation resistance is higher than 1 mega ohm. If the insulation resistance is higher than 1 mega ohm, the chance of accidents are quite less. Now, these regulations, I had discussion with a lot of electricity supply companies, and in fact, the old engineers know about the regulation, but the new generation engineers doesn't even know about this requirement. As a result, such tests are never carried out by the electricity supply company, not across India, but in most of the places. Another threat which I explained during my last presentation was class 5 and class 2 conductor. In the final circuit, especially inside our houses, especially inside the small scale industries or the low voltage final circuit wiring, or we use the word conduit wiring. We use copper wires in conduits, especially up to 10 square mm copper wires are recommended, and we use copper wires. Now, copper wires are available in two types of conductors, class 5 conductor and class 2 conductor. Class 5 conductor is having a higher resistance. In comparison, class 2 is having a lower resistance. The standards, be it IS standard or IEC standard or whatever the standards always consider a class 2 conductor for calculation of different derating figures in a electrical installation. You know, sometime in the manufacturer's catalog, they must have written the current rating of the wire is 15 amperes. But you cannot use that wire for 15 amperes always. You have to apply the derating factors depending upon the length, depending upon the filling in a conduit, and so on. So in all these cases, class 2 copper is considered, whereas in India, we always use class 5 copper conductor, which is having a higher resistance. Somebody asked me how much is what is the energy loss and what is the payback period of a if we change from class 5 to class 2 conductor, what is the payback period? So I just calculated, not me, it is done by Mr. Sumesh V, electrical inspector of Wayanad, Kerala state. He helped me, or he made this particular table, and finally our calculation, for example, 1.5 square millimeters of wire, imagine 5 ampere current flows through this particular wire. We took a case of 10 coils, approximately, maybe typically for a small scale industry or a small house, 10 hours per day it is working with an actual temperature of 30 degrees centigrade. So this actual 30 degrees centigrade, we actually took these values in a very, very moderate way. The actual temperature probably sometime, is much higher than 30 degrees. Once when the temperature is higher, resistances are also higher, then we are actually ending up into trouble. We have calculated approximately 5 rupees per kilowatt hour, 5 rupees per unit. Here you can see 5 rupees per unit. And the cost of class 5 wire we took from the market 1,254 per coil, and class 2 wire 1,392. Class 2 copper. The difference is the wires are thicker, the strands are thicker. As a result, probably the copper, maybe a little bit more copper has to be used. I'm not aware of such things. That is the job of the wire companies. Anyway, for a safety engineer, what is important is the offered resistance of that particular wire. Class 2 wire has got a lesser resistance, higher cost. Then with our calculation, we have established that the payback period is less than 3 years. So that means in an installation, if you buy class 2 conductor, of course you will be paying a little bit more, but your payback is within or less than 30 years, 3 years. Now this is actually a moderate calculation, but in a practical case, if we calculate, the payback will be even faster. And what additionally you get is increased safety with a class 2 conductor, because at the end of the day, in case of a problem, in case of an overcurrent, or in case of a short circuit, or in case of earth fault, the protective device should trip. For the protective device, especially for MCB to trip, the fault current comes into picture. Once when the fault current comes into picture, the impedance of the circuit comes into the picture, and the impedance is greatly affected by the resistance of the conductor. So this is a very, very important subject. Last time, in the last program, I made some statements about thermography, and there were a lot of questions in that particular program. I would like to clarify that. I could see that there were about 6-7 questions on thermography, because I made a statement that thermography cannot improve electrical safety in a building. So somebody asked, how come, what is the reason for making that kind of a statement? So I will explain the reason for that particular statement. Let us analyze whether the thermography and arc flash analysis help low voltage system improvement. We are talking about low voltage, not about the other voltages. Please understand. In low voltage engineering, there are fundamental safety requirements. That means the basic safety requirements. It is included in the IEC 60364. That is the IEC standard. In the British standard, the same point is BS7671 or NEC of America, NFPA 70 or IS732 to our, the code of practice of wiring. In all these standards, of course, for us, IS732 is important. We are not bothered about the British standard and American standard. I am just showing you, just for your information. Don't follow British and American standard. We are Indians. We should respect and we should follow our standard. Now, to achieve fundamental safety, 16 inspection points and 10 tests are included in this standard. I repeat, 16 inspection points and 10 tests. Now, if you are making these testing, inspection, and certification TIC points, these are actually mandatory. These are recognized as mandatory safety measures, which is followed worldwide because the IEC 60364 is followed across the globe as the basic electrical safety requirement. Now, in American standard NFPA 70B and 70E, for OSHA or for to comply to the other enhanced safety measures, additional safety measures, or let us say extras, let me say, thermography and the arc flash studies are considered as one among several measures. Please understand, one among several measures. Thermography is not the only one. Arc flash study is not the only one. These are considered one among the several safety measures. But fundamentally, you have to have this 16 plus 10, which is mandatory. And these, the additional things, thermography and arc flash, these are, let me say, extras. After achieving fundamental safety, extras are always good. Extra tests ensure additional safety for you. But imagine without fundamental safety, if you do only thermography, what kind of guarantee it can give? It cannot give any guarantee. Extras will not guarantee safety. First, you make your fundamental safety proper. Then you make whatever the extra things which you can do. As a result, you increase, you enhance the safety. But if you take pictures in a thermography, thermal camera, and realize, or if you believe that every place is cool, as a result, we are not into trouble or expecting safety, is not the correct way. And recently, in one of the building, I have even saw a new apartment, a high-rise apartment in Bombay. They are doing thermography to find out loose contacts in the wiring. So they are not doing any of the fundamental safety measures. I would say 90% of the fundamental safety measures are missing. But finally, a thermography for the wires which is enclosed inside the conduit are made. This is really, this is not at all acceptable. This is, you are violating the basic requirements. So as a result, the statement which I made last time is IEC 60364 or our Indian standard, the IS732, do not recognize thermography as a fundamental test in an LV, low voltage electrical installation. So inside a building, inside an electrical installation, thermography is not recognized as a fundamental safety requirement. If you have fulfilled the fundamental requirement, you can do it extra. So what I would recommend is you first do the test as per the IS732, rectify all the mistakes, then you carry out your extra tests, such as such as your thermography or arc flash study or whatever. But fundamental is there. Without fundamental, if we do only the advanced things, of course, it won't work out. So this is the reason I showed last time that this is misguided, because you please understand that behind every propaganda, there is an industry. Let me repeat, be it a standard or be it a new device or product or service or whatever it is, Behind every propaganda, there is an industry. Thermography, of course, will identify the hotspots, and it can avoid the hotspots, and it will increase the safety. But as I said, example, hospitals conduct thermography and believe they are safe. We were in touch with, in last year after the fire accident, I was visiting some of the hospitals and I asked them how you are ensuring safety. Then the reply is, no, we did thermography, and we do thermography every 2 years to ensure safety. But when I asked what about your fundamental testing, in fact, they were never aware of it. So the fact is, protective conductors are non-current carrying. Loose contacts in an earth wire cannot be identified with thermography. And if you really wanted to find out loose contacts, what you should do is you should do the test called as a continuity resistance of the wiring, which is the test number 1 in the sequence of 10 tests recommended in IS732. The second test which I would recommend is the fault loop impedance test, which is the 6th test in the sequence of the IS732. These tests are included in IS732 1989 Code of Practice of Electrical Wiring, 1989. 32 years passed. So many fire accidents, so many electrical accidents in our country. I am yet to see a building which has completed 100% testing as per this particular standard. Hospitals who conducted these tests as per the Code of Practice of India, especially the National Electrical Code 2011, I have put as 0% because I am yet to see one building where these tests are made. What is the reason? It is because of the no awareness. People are not aware. Now, people ask, what are those inspection and testing points? I have put the inspection points 1 to 19, but all the 19 are not required sometime. The last one, compliance to the EMIMC requirement, that is not mandatory until yet, but probably in future it will come. I will explain in detail the inspection point number 2, presence of fire barriers, other precautions against propagation of fire, and protection against thermal effect. This I will explain a little bit later, but what you should understand that there are 16 or 17 inspection points and there are 10 tests. One of the test number 2, insulation resistance. The minimum insulation resistance between a current carrying conductor and the earth must be higher than 1 mega ohm. If the resistance is lesser than 1 mega ohm, you are supposed to rectify the problem immediately. Now, I have also included a test number 11. The test number 1 to 10 ensure that your electrical installation, the wiring and the protective devices are operating in a very good condition. But tomorrow, if you plug in some device, portable devices are plugged into your good electrical installation, and if you have a portable device which is faulty, of course, fire can happen. In Europe and other countries, they started doing the test number 11, which is called as PAT, portable appliance test. Before you put the portable appliance into your good electrical system, you are supposed to do this test, and you connect only the good electrical apparatus or good portable appliances into your system. As a result, you are able to achieve the safety in a whole way. So basically, if the equipment standards are followed and if the equipment are tested as per the Indian standards, the equipment is unable to create a fire. The chance of fire from the equipment is absolutely less because these tests are mandatory. Number 2, if the 16 inspection and 10 tests are carried out in your electrical installation, plus if you are doing some kind of periodical testing, your installation deteriorations can be identified very, very fast. Number 3, if you are doing PAT, portable appliance test, you will be able to find out the faulty equipment. So all these things are included in the standard, but the question is who is following? Now I go to the second part of the presentation. What is the common cause of ignition of fire? The IEC standard 60695 but this has got several parts. It has recognized how to handle the electrical fire situation in a building. Actually, we can use this methods for fire investigation and failure analysis. In case of a fire, a person who knows the standard, he can actually do the investigation in a better way. But as I said, it is not one standard, even though I put as one. There are several substandards. I think there are about 30 plus standards. So the first cause of electrical fire is short circuit. Why does it happen? It is happening because of a direct contact of conducting live part at different potentials. So your conductors, your wires are having different voltages, and due to an insulation degradation or insulation failure, if these two wires are in touch, of course, you get a short circuit. The second problem is gradual degradation of the components. So that means the devices which is used in your equipment, such as capacitors or MOVs or diodes, if it degrades or in a winded a transformer or a small instrument transformer, if the winding insulation fails, of course, it can also create a short circuit. The third part is the sudden failure of a component in the internal part of an equipment. These three are the recognized origins of short circuit, and the consequences or the effect. The effect number one, always, protection device may not get activated. The most important point is, in case of any abnormality, the protective device is supposed to operate within certain time. In case of an overload or overcurrent, for example, the wiring and the MCB, the protective device, are selected in such a way that the conventional disconnection time and the conventional disconnection currents are the whole system is able to withstand. So this we explained last time, but what I am explaining here is the protective device must get activated, and if the protective device fail to get activated, we will be in trouble. One of the factor which is influencing this parameter is earthing. In case of an earth fault, if your earth fault return path is poor, of course, your protective device don't operate. As a result, you will get into trouble. Number two, the rise in temperature is significant after very short time and maybe localized. That means a hot spot inside your equipment in a very small area. And if the temperature is sustaining for a longer duration, of course, the short circuit happens. And the other reasons are written here. Production of flames, ignition can occur locally in surrounding components, possible release of glowing material. Actually, I am only taking some of the bullet points from the standard to tell you that these are the reasons, but each reason, the reasons can be analyzed into detail if we do an investigation. Number two, accidental sparks or arcs. Here, we must understand that there are some electrical apparatus which is inherently it creates arcing while operation. But that arcing is not supposed to ignite a fire. That is much more important. Then accidental sparks are arcs. How does it happen? It can be external to the product. For example, over voltage of the system network. What does it mean? Over voltage of the system network, in the sense, system network means the electricity supply. Due to over voltage in the electricity supply, imagine the line to neutral voltage in the electrical system is 230 volt. But due to a fault on the high voltage side of the transformer, the low voltage side can experience a voltage of up to 1200 volt for 5 seconds between each line and the earth, or neutral and the earth, up to 1200 volt for 5 seconds. Imagine if your equipment is unable to withstand 1200 volt, of course your equipment will fail and it can create a fire. Number two, this 1200 volt which I told, that is the maximum limit which is allowed inside a wiring. This also means the designer, the electricity supply company, has to take care of the transformer in such a way that more than 1200 volt is not allowed inside your electrical installation. But it is very unfortunate that this protective measure is not very well taken care. If you really ask how much voltage can go into an electrical installation, low voltage electrical installation, due to a fault on the high voltage side of the transformer, I would say sometime it is 10 kV or 20 kV or 50, 60 kV. Such high voltages can come inside our electrical installation. But remember, the maximum allowed is 1200. So the design must ensure that more than 1200 volt is not allowed inside your electrical installation due to a fault on the high voltage side. This is the exact part of this one line. Then internal causes, sudden failure of components, the consequences are written here. Protective devices may not get activated. That is always the first point of the effect. If the protective devices are not getting activated, or if the MCB didn't trip, of course we will be in trouble. The third problem is high transient peak current due to some kind of switching action, due to lightning, due to starting of a motor, due to switching of a long array of tube lights, and so on. So these also create some insulation failure where the protective device should trip and work and protect your installation. And the fourth cause is abnormal temperature rise due to overcurrent in a conductor, probably due to a defective conductor, probably due to leakage current, loose contacts, failure of a component, mechanical distortions, seizure of a motor shaft. That means the motor is locked and the motor is not running. Premature thermal aging. Why I'm showing all these reasons are, there are several reasons which could ignite a fire in a building. Generally, we call this as arc, spark, overload, short circuit, earth fault, and so on. But if we go into deep, there are several reasons, and there are established methods to investigate or to analyze such problems or failure analysis. These are actually very well documented in the standard. Now, protective device. In each of these problems, the protective device is supposed to work and it is supposed to disconnect the supply within certain time. You have no other option. The only option is your protective device should trip. For that, we have different kind of protective device. The first one is of the category OCPD, overcurrent protective device. Means an MCB, MCCB, fuse, and so on. Now, once when you select this protective device, of course, the current rating, there are several measures. For example, if you select an MCB, what is the load requirement, then the sizing of the conductor shall be calculated based on the load requirement. The sizing of the MCB has to be calculated based on the size of the wire, and so on. I'm not going into it, but you always should keep in mind that there is a parameter called conventional disconnection time and conventional disconnection current. What does it mean is, the conventional disconnection current is 1.45 times the rated current of that particular protective device. Say, for example, you have a 10 amps MCB. This 10 amps MCB can take a time of up to 1 hour to trip in case of if the current is lesser than 1.45. What does it mean is, you have a 10 amps MCB, your overcurrent is 14 amps. How much time will it take the MCB to trip? Up to 1 hour. So your electrical wiring must be able to withstand that much the conventional time it is supposed to withstand. So the electrical design, we are supposed to take care of this particular subject. The overcurrent, it can cause due to overload, short circuit, or earth fault in a TN system. So OCPDs can be used against overload, short circuit, and earth fault in a TN system. Of course, overload and short circuit in all the systems, and earth fault in TN system. Then the second protective device is called as RCD, residual current device. We call it as RCCB or CBCT into the plus the earth fault relay. Here, what you should understand is the disconnection current. The maximum allowed disconnection current is 30 milliampere. That means a leakage of more than 30 milliampere. The device RCD is supposed to trip. 30 milliampere is the shock protection in dry areas. This is the maximum current allowed current for shock protection. That means if you wanted to get protection from electric shock, you must use an RCCB of lesser than 30 milliampere. 300 milliampere is calculated as the requirement. Lesser than 300 milliampere is for fire protection. So there are two things: 30 milliampere shock protection and 300 milliampere fire protection. Of course, the 300 milliampere fire protection, we must understand that this is based on a 230 volt line. If the operating voltage is a little bit higher, then there is still a subject of debate going on. So these devices can be used as a residual current device. For non-electrical engineers, you can, I have put a tricky way: current escaping from the circuit. So residual current is the current which is not flowing through a circuit. It is actually escaping from the circuit due to some insulation failure or some leakage. So if the current escaping from the circuit is more than 30 milliampere, your RCD trips. So this is what I mean in RCD, and these devices can be used only for earth fault protection, not for overload and short circuit protection. The third kind of protective device is called as AFDD, arc flash detection device. These devices are used for to protect a circuit from loose contacts. Let us say you have a phase conductor, there is a loose contact, and due to arcing, probably over a period of time it can ignite fire. But this AFDD protects that particular circuit from arcs. So arcing in a conductor due to loosened contacts can be done with AFDD, but don't think that arcing a loose contact in an earth wire will create a tripping, because the earthing is not considered here. Only the line and neutral in case of a single phase circuit. If there is a loose contact, this device will trip. Then the next protective device which is required in your network is the SPD, surge protective device, and I have put and other overvoltage protective measures. And these protective measures actually protects your insulation. SPD, are we using SPDs in every electrical installation? This is quite less. I would say not much. Only in few places, yes, SPDs are used. But the next point, and other overvoltage protective measures, which is very, very important. Say, for example, as I said in the previous slide, a fault on the high voltage side of the transformer, it can create a failure and shock hazard inside our house. So those overvoltage maximum allowed inside our building is 1200 volt for 5 seconds. More than that is not allowed, and we need to actually implement all these protective measures in our building. So I would recommend that the electrical designers, those who are listening to the program, please start looking seriously into this particular subject. Then electrical energy as a cause of now let me ask, am I audible, Mr. Dominic? I hope.
Yes, you're audible.
Okay, thank you, sir. Because sometimes sitting alone and talking is too much boring. Thank you, sir. So now, electrical energy causing fire. The IC 60695. One misinterpretation which I wanted to tell you is arc. Whether arc can ignite fire. Arc is a high temperature luminous electrical discharge across a gap. Temperature within the arc can go to several thousands of degrees, but arc is not an effective ignition source for many fuel materials. Even if solid combustible materials, arc cannot ignite because it's for a very short time. Continuous arcing also is considered. The arcing is so brief and localized that solid fuels cannot be ignited or can be difficult to ignite. Fuels within a high surface area to mass ratio may be ignited when contact with the arc. So basically, if we think that the arc is creating a fire, then we have to actually consider the other situations as well. Arc as such cannot ignite fire, provided there is no combustible things nearby. Most of the time, the resistive heating is creating the failure or the fire. Resistive heating, again, the standard established how to calculate it, what is the energy involved, what is the duration involved, and how much energy, how much duration the equipment can withstand. All these things are actually very well documented, and these can be used for investigation and failure analysis. I am not going much into deep because these are subjects which require a lot of attention. deep attention is required. One simple concept which is followed is any electrical apparatus which is consuming a power lesser than 15 watts is not supposed to ignite fire. No chance of ignition of fire from an electrical apparatus consuming a power lesser than 15 watts. The same way, a device which is consuming lesser than 100 watts, ignition is possible only under certain condition. What are those conditions? The condition is if the if some ignitionable things are nearby, probably the other items start burning. An electrical apparatus higher than 100 watts, of course, if the duration is high, of course, the chance of fire is very high in those devices. These are actually the power classification. With respect to time, in the chart, please note that in the x-axis I am showing the time in seconds, 1, 2, 3, 4 up to 20 seconds, and on the y-axis you can see the power in watts. Power means the power rating of that particular device. So if the power rating is lesser than 15 watts, the chance of ignition of fire from that particular equipment is lesser. If it is lesser than 100 watts, between 15 to 100 watts, probably it may or may not create fire. More than 100 watts, of course, it's danger. Also, the peak power not limited to, I have put 1000, but not limited to 1000 watts. It can be even higher. A device which is even 2 kilowatt, 3 kilowatt, 4 kilowatt. If we are able to limit the fault to less than 15 watts within 3 seconds, then the chance of ignition of fire is less. In simple words, if your MCB trips within 3 seconds, the fire chance is less. Similarly, if the protective device is operating within 5 seconds, the chance of fire is, ignition is possible only under some condition. These are actually some of the concepts which is considered for designing an electrical apparatus plus designing an electrical circuit with respect to safety. So based on this, power source classification comes into picture. I explained this in my last class. Protection from fire of an installation, how does it create? It is due to several reasons, heat accumulation, and I would like to skip this particular part. There are several reasons. One of the reason is in case if you have an equipment which is creating a temperature rise, you should take care of it and you should mount it appropriately so that the temperature rise is not creating a fire hazard. Mounting is important. Special protective devices such as arc flash detection devices are being recommended in the upcoming National Building Code, especially for premises with sleeping accommodation. That means the bedrooms or the hotel rooms. And in special cases, not everywhere, but in some places you need to have the additional safety measures such as arc flash detection devices. And now today we advertised that we will be discussing more about the condition of evacuation in an emergency, which is very, very important. So in case of a fire, in case of an emergency situation, what are the conditions with which the electrical system should satisfy in order to evacuate people from the fire? There are 4 categories recommended in the electrical engineering standards by IEC 60364, followed worldwide, be it Europe or America or whatever. These classifications are called as BD1 to BD4. BD1 stands for low density easy exit and the BD4 stands for high density difficult exit. So now, one of the conditions which we need to understand is this classification shall be done by the authority, those who are involved into fire, like say for example, fire and safety department. Basically, they have to set, okay, the building more than 15 meters height and more than this much people are coming under BD2 category. Then they say, for example, a hospital 10 floors coming under BD4 category. So the other categorizations are also there with respect to content of the building, like explosives or flammable things, plus other classifications, say for example, a hospital where people are unable to move. So those classifications are also there, but I am just focusing into the classification or condition of evacuation in case of an emergency. 4 classifications are made. Each classification, such as BD2, BD3, and BD4, special requirements are there. Special wiring rules shall be adopted while designing and erecting the electrical installation. That is more important for us. Now, when it comes to the National Building Code, Part 4, Table 7 explains the classification minimum requirement of firefighting installations. Now, in the upcoming National Electrical Code 2000, probably 2022, in maybe 3-4 months it will come. What we did is we tried to include, or we tried to combine the requirements of NBC and the IS732 in a different way. If we look at the NBC, service ducts and shafts, 120 minutes, it should be fire resistant. The electrical installation emergency services should have 120 minutes fire resistance. Whereas if we look at the IS732, minimum requirement is 1 hour. But anyway, we have to follow the National Building Code. Emergency lights should switch over within 5 seconds. Battery packed emergency lights are not allowed. These are actually influencing the safety. Now, in in the National Electrical Code, what we did is we tried to simplify the Table 7 of National Building Code and tried to put it in a condensed way with the classification. Building height lesser than 15 meters, more than 15 meters. Because in the regulation, somewhere in the regulation, I think in the 36, regulation number 36 says anything more than 15 meter is considered as a high-rise building. So we also took that particular classification. Buildings category A1, A2, A3, and A4, there if it is lesser than 15 meters, BD1 is the category. And like this, you know, every building, category A, category B, category C, category D, all these are classified. The electrical engineering standards are also classified into it. And now the balance, Group E building, Group F building, Group G, and Group H. So everywhere the building classifications are the electrical standards, and the NBC is coordinated in such a way that most of the electrical requirements in future, if somebody asks, look, NBC is categorizing building into this way, and in electrical it is in a different way, where is the coordination? So such answers are handled very well. There are 2 subjects which is influencing the building classification. One is what kind of special electrical installations are required in order to handle evacuation during an emergency. And the second one is what is the periodic frequency of periodic verification. The regulation number 30 says the insulation resistance shall be tested in every 5 years, but that is actually applicable for the electricity supply company. Whereas inside the electrical installation, this table has been included in the upcoming National Electrical Code. I think before National Electrical Code, next month probably BIS is coming out with a new standard which is called as a guide for implementing electrical standards, guide for implementing standards and regulations. So this guide also included the tables which I am showing. Basically the building classification and the periodic verification has been incorporated as in line with the National Building Code. Now, what do we require in this classification, BD2, BD3, and BD4? There are special requirements. You can go to clause number 4.2 of IS732, where these classification, these special requirements are very well documented. Say, for example, in condition BD2, BD3, BD4, wiring shall not encroach on escape routes unless the wiring in the wiring system is provided with the sheath or enclosure provided by cable management system itself or by means. Basically, what it says is you cannot hang your wires in the escape route. You have to fix it properly, and you have to have special protective measures. Number 2, you cannot use normal light fittings. You need to have special light fittings. So all these special additional requirements are included, and you can see this in the IS732 clause number 4.2, sorry, 4.3, it's not 4.2. Now, Wiring system in escape route, actually the wires and the wiring fixing materials, it has to satisfy some special requirements, especially on escape route in buildings BD3 and BD4, because the escape route is not supposed to have a fire or a smoke up to 120 minutes during evacuation or up to certain time during evacuation. I'm just showing you some of the requirements. I didn't put all the requirements here. In condition BD2, BD3, BD4, wiring system that are supplying safety circuits shall have a resistance to fire rating of either the time authorized by the regulation for building elements or 1 hour in the absence of such a regulation. This is what the IS732 says, and as per the NBC, it is 120 minutes. So basically what it says is the wiring must be able to withstand 120 minutes. It is not only the wire. Please understand, we have there is a new IS code for fire resistant wires, but using the wire alone will not ensure safety. The entire electrical wiring, the fixing materials, the distribution board, the entire system should have a function guarantee of 120 minutes. I would say 120 minutes is a little bit larger. It is a little bit higher. Even 60 minutes or 1 hour itself is enough. But anyway, it is the subject of National Building Code. So like this, a lot of additional safety measures are necessary. I skip these points. Anyway, the presentation is available. We will send to you in the mailer. You can take it, or you can simply go to the IS732 clause number 4.3. All these parts are explained. I skip some of them. Now, as I said, I will explain about the out of 16 parts, the inspection clause number 2 explains how to inspect the fire barriers, other precautions against propagation of fire, and the protection against thermal effect. In the previous slides, which I skipped, I told there are several conditions required. Condition number 1, presence of fire barriers. In the standard, it is written only as presence of fire barriers. What does it mean is the person who is doing the inspection should find out whether fire barriers are installed at appropriate location. So then he also understand what is this appropriate location. Say, for example, on the vertical shaft, probably every floor, on the horizontal shaft at certain location. So the person should understand it. Then he has to find out whether the ceiling material is able to handle 120 minutes as per the National Building Code, whether it is tested, check the usage as recommended in the test certificate and by the manufacturer, and whether the markings and labels are there. So it is the job of the inspector to ensure that all these 5 points are inspected and he is recording it in his report. As a result, out of 3, 1 of the requirement is handled. The second requirement, the propagation of precautions against propagation of fire. How you are stopping the fire from propagating it into critical areas. Here, say for example, fire resistant materials in respective locations, routing of conductors, selection of materials and devices in escape routes. These also must be inspected. Number 3, protection against thermal effect. As I said, you will have some equipment which is producing heat. Have you installed those equipment in such a way that the heat produced inherently because of the operation of the equipment is not destroying the neighboring installations? So all these 3 parts are coming under fire inspection. So the sequence: fire barriers with 5 parts, precaution against propagation of fire, and protection against the thermal effect. All the 3 are important. Now, with the coordination of the testing and the inspection, which is as per the upcoming National Electrical Code as well as the guide, we will have more clarity on this particular subject. With respect to insulation resistance, as I said, the regulation number 33 is very clearly mentioned. Minimum 1 mega ohm within your electrical installation between current carrying conductors, that means phase and neutral, to earth. Minimum 1 mega ohm. But we always use devices which is violating this requirement. One of the example is inverter. Most of the inverters which we use in our residences, houses, it has only single phase changeover. only phase is changed over. The neutral is not running through the inverter. The same neutral is circulating everywhere. This can create a backfeeding and shock hazard. Lot of incidents are recorded. Plus, this can also create insulation failures, and this can also create fire hazards. So, while using inverters, please ensure that the requirement on the right side, which I am showing, both the phase and the neutral must be isolated. Inverter or UPS circuits shall have separate the neutral phase, and the neutral must be segregated from other parts of the wiring. But unfortunately, the inverter with two-pole isolation is quite rare in the market. We have to really search for it. So rather, I would make a statement that we actually use product which is inviting fire rather than protection, inviting. The other product which is used, which is actually inviting fire or accident, is called as a digital grounding device. This is a new trend, or there is a new trend in the industry to use this particular device. The manufacturers claim as a solution for all your problems. They say this will reduce, you don't need earthing, this will absorb fault current, this will absorb neutral current, this will reduce neutral to earth voltage, and all the problems which is faced by the electrical engineer on a daily basis has been solved by this particular product. This is what the manufacturer claims. But actually what they do is they short the phase and neutral inside this particular device, violating not only the regulation, it is a violation of all the safety regulations and all the safety standards. I would recommend, if you use this kind of a device, please remove it immediately. These devices can create harm anytime. It can create a shock hazard in your building, it can create fire hazard in your building, it can create a failure of electronics in the parallel circuits. Please understand, you are using this device for one circuit, probably that circuit, the problems are camouflaged for a certain time, but problems will come on the other circuit. So, rather than protecting, we actually use devices which is inviting problem. Now, one solution which we are trying to develop for the last 1 year is we are going to present it during the 25th year of Cape Electric, probably next month. We are coming out with a new solution, SOLVE, safe operation of low voltage electricity. This is a digital based or a software based solution which will explain you step by step what kind of inspection or what kind of safety audits are necessary in a building. As I said, the 16 inspection points and 10 testings are mandatory, fundamentally required in every electrical installation. But since the awareness is quite less, people don't know really what to do and how to do. Now, this software is, it will help you to make the testing, inspection, and certification of a low voltage electrical installation. This also helps you to investigate in case of a failure or in case of a fire accident, because the information, the technical information from almost all the standards will be inbuilt into this particular software, so that step by step you will be able to select and find out the problems. Plus, the software will also help you in making safety measures for a special location, such as the operation theater in a hospital. So we are building, or we are making this software since 1 year. We have a team of 7 engineers working in Cape Electric. Now I will show you the software probably in next 2-3 minutes. So what we are aiming is SOLVE as a partner in electrical safety. We will support the industry in designing the system. We will train you. We will help you in verification of the basic drawings. We will help you in compliance to ensure the compliance to standards, and we will help you in support during erection, testing, inspection, and certification. We can help you in long-term contract for periodic testing, record maintenance for future, and the last one, PAT, portable appliance test. So here our software is made in such a way. Please understand, this is not a software made in an Excel. We have put a lot of effort and a lot of energy into it, a lot of money into it. So we'll help you to solve your lot of problems. So this is the end of my presentation. But anyway, as I told, I will show you the software as well. One moment, please. I'm sure you are able to see the new screen. Mr. Dominic, are you able to see the new screen?
Yeah.
The presentation. Yeah. So this software, of course, there is a method to log in and all. This software will help you. Say, for example, these are the data which need to be fed into the software. Now, starting with the basic information, like what kind of electricity supply you are having, whether what is the size of the transformer, what kind of supply, TNT, TNS, TNCS, what kind of conductors are used, what kind of protective devices are used at the incoming. Then the supply characteristics, different supply characteristics. Say, for example, you have the mains incoming from the electricity board. You have the alternate supply. Alternate supply, if we select, let us say you have alternate supply and you have AC supply, then it will ask a lot of questions. Then what are the particular, what kind of part of the building you are going to handle, details of main protective conductor and so on. The various inspection points in the sense, anyway, I am unable to go to that particular part. Various inspection points. Actually, here the real software starts. One moment, I can show it. Basic information, supply characteristics, inspection. What kind of inspections are required? As I said, the 16 inspection points. All the 16 inspection points can be recorded in the software. Please understand that we have also included some additional features, because the 16 points from the IEC probably sometime is not applicable to India. We need to actually have something extra. So those are also included in the system, say for units. It is not one question. Please look at the inspection points in the consumer unit. Section 1, consumer unit at the distribution board. Section 2, distribution board, what kind of switches are used, what kind of protective devices are used. It is actually a comprehensive method. Then we go to the testing part. There are basic testing features and the final, the detailed testing in the sense. Here, circuit details. I'm just scrolling from left to right. There are several parameters which need to be tested. Actually, these testings are one time. Once when you do a testing as per this particular software, and finally on the summary, you will be able to get how important or how safe your electrical installation and what kind of improvements you are supposed to make, what kind of rectification you are supposed to make in your electrical installation. So with this, I would like to stop my presentation. Thank you very much for